Okay, next problem. Another problem asked in mains 2020 from differentiation. Look at the problem. This relation is given y into root 1 minus x square is equals to k minus x into root 1 minus y square. And in this relation, y of 1 by 2 is given as minus 1 by 4. Y of 1 by 2 minus 1 by 4 in the sense if x is 1 by 2, y is minus 1 by 4. Okay? We need to find dy by dx at x is equals to 1 by 2. Actually, for the given relation, k is unknown. Okay, we don't know about k. But since k is a constant, on differentiation, k gets cancelled, right? So no need to bother about that k. Right? We need to find dy by dx at x is equals to 1 by 2. And the question itself mentioned that at x is equals to 1 by 2, y is equals to minus 1 by 4. These two together we need to use to find dy by dx at this point. So now dy by dx. So this is the given relation. Okay. Then you just differentiate that relation, right? If you differentiate this relation, what will happen? If you differentiate with respect to x, here we have y into root 1 minus x square product of 2. So can be written as first function y into derivative of root 1 minus x square. 1 by root 1 minus x square. See, for root x, 1 by 2 root x, right? 1 by 2 root 1 minus x square into minus 2x. For this 1 minus x square minus 2x. Plus root 1 minus x square into derivative of y is dy by dx. This is left side. Coming to the right side, for k it is 0. And here minus x into root 1 minus y square. For root 1 minus y square, 1 by 2 root 1 minus y square into minus 2y into dy by dx. Okay. And then since we have minus sign here, so minus root 1 minus y square into derivative of x is 1. We just used the product rule both in left and right side by neglecting k since its derivative is 0. Okay. Now finally we need to calculate dy by dx at this x is equals to 1 by 2 as well at that y is equals to minus 1 by 4. We need to replace x and y with 1 by 2 and minus 1 by 4 so that we will get the answer. Okay. Here 2 and 2 gets cancelled, right? Okay. Here also 2 and 2 gets cancelled. So in two terms we have dy by dx. Okay. In the other two terms we don't have that dy by dx. If you try to simplify this, it can be written as minus xy by root 1 minus x square. Okay. If you send it that side, we have dy by dx into root 1 minus x square minus x and minus y is xy. Coming to this side will become minus xy by root 1 minus y square is equals to the other part. This is again xy. So when sending that side becomes xy by root 1 minus x square minus root 1 minus y square. Okay. So finally we have this. So now we need to replace x with 1 by 2, y with minus 1 by 4. So x 1 by 2, y minus 1 by 4 in the sense xy is equals to minus 1 by 8. So everywhere you just replace x and y so that you will get the answer. Okay. We just try to simplify this. Yeah. I am using this space dy by dx into root 1 minus x square. Look here, x is 1 by 2. X square is 1 by 4. 1 minus 1 by 4 is 3 by 4. Root of 3 by 4 is root 3 by 2 minus xy. X into y is minus 1 by 8. Minus of minus is plus 1 by 8 into root 1 minus y square in the denominator. Y square is 1 by 16. 1 minus 1 by 16. 1 minus 1 by 16 is 15 by 16. If you reciprocal it, you will get it as 4 by root 15. Okay. Is equals to right side xy. Xy is minus 1 by 8 into root 1 minus x square is root 3 by 2. Since root 1 minus x square is in the denominator, we will write it like this 2 by root 3. Okay. Minus root 1 minus y square. Y is minus 1 by 4, y square is 1 by 16, and on simplification this is root 15 by 4. You just have a look. You just try to simplify. On simplification, you will get dy by dx is equals to minus root 5 by 2 finally. Okay. First of all, this is the function. Differentiate with respect to x and then collect dy by dx in terms of the other x and y relations. Okay. Replace x with 1 by 2 and y with minus 1 by 4. At the end, dy by dx is minus root 5 by 2. Okay. Have a look.